As you may know, Weka is one of the most powerful tools for data mining, developed by Waikato University. You can easily experiment with data preparation, data visualization, classification algorithms, and clustering algorithms. So we will use this tool for the first assignment. So if you follow the lab instructions here, there are several activities you can do with Weka. So I will go through this step by step and show you how can you prepare your data and visualize the data. As I said, there is a link here for you to download Weka. Download is easy. It is Java based. You can customize the algorithms by writing Java code. Even there is a command line interface if you want to run some tasks using command line, but we are not going to use this for this paper. We use the graphical user interface, which is very easy to use. So the first thing I want to share with you is the format of data files native in Weka. The format is called ARFF. So if you go to Weka folder after installation, it would be somewhere here in program files. You will find it here, Weka 3.8 for example. There is a folder here named data. You can find some samples of data files here. For example, this weather.numeric is one of the samples. I will have a look here. The format is called ARFF, and as I said, this is the native file format in Weka. So it's a text file. You can edit it with Notepad++ or Notepad. The format of an ARFF file is something like this. It starts with the name of the data set by using this tag relation. After relation, you will choose a name for your data set. The name here is weather, for example. This data set is used to predict the weather situation and is it safe or is it okay to play outside or not. So this is the application of this data set based on some weather parameters. We predict is it good for playing outside or not. After the name of the relation, we will have the section for defining attributes. So for each attribute we will have one line here starting with tag attribute and then the name of the attribute. So the name of this attribute, for example, is Outlook. The type of the attribute is nominal with 3 possible values. So Outlook may have 3 possible values: sunny, overcast, and rainy. The second attribute is temperature. The name of the attribute is temperature, and the type of this is numeric. Okay. The third attribute is humidity. Again, it's numeric. The fourth attribute is windy. It's nominal with true and false as possible values. And the last attribute, which by default is considered as class attribute, is called play. This is also nominal with 2 possible values, yes and no. Yes means that it's okay to play outside, and no means no, we better keep inside. After declaration of attributes, we have the section of data, actual records. This starts with this tag data. Each row will show one record. So, for example, the first row, which shows the first record, has the value sunny for the first column. If you look at here, the first column or the first attribute is Outlook. So for the rest, for the first record, the attribute Outlook has the value sunny. Temperature is 85. Humidity is 85. Windy is false, so there is no wind. And play outside? No. This is the first record, this is the second record, and so on until this one, which is the last record. As you see, some of the records have the class value no at the end and some of them yes at the end, based on weather temperature, weather outlook, and humidity and windy. Okay, this is the format of an ARFF file. If you want to create something in this format, you need to think of these different sections: relation name, attributes, and data. If you want to open this file in Weka, you need to click on Explorer, and when you come to Explorer, there is a button for opening a file. So you click on Open File, and then you need to browse to find the file. So I will go to the same path and find the folder for data files in Weka. Then you will see the data files here. Remember, ARFF is not the only format acceptable by Weka. There are some other possibilities. So if you look at here, these type of files could be acceptable. For example, CSV files, JSON files, for example. So it's up to you which type of file you want to open. The file I was looking was weather.numeric. So there is another file, iris. If you remember, I told you about this data file. It's about several flowers of different types and different characteristics of petal widths, petal lengths, and so on. So if you want, you can have a look at this also. Let me open weather.numeric file here. I will click on that, and instantly you can see some information about the file here. In this part, you will see the attributes: outlook, temperature, humidity, windy, and play. Right? There are several information here, but before that, let me show you the last attribute, play, which is by default considered as the class attribute. So it seems that there are in total 14 records in the data file, 9 records of class yes. So it shows you that this attribute type is nominal, 2 distinct values, yes and no, 9 records of type yes, and 5 records of type no. So for these two classes, it uses a histogram to compare them and different colors. So for yes class, it uses a blue color. So 9 records of class yes versus 5 records of class no in red color. This is for the class attribute. Let's have a look at the other attributes. Click on Outlook. There are 3 distinct values for this attribute. This attribute type is still nominal. There are 3 distinct values: sunny, overcast, and rainy. This shows you the distribution of the records for each value: 5 records sunny, 4 records overcast, and 5 records rainy. The class colors is used here to differentiate the class of records for each value. So the first column shows the records having sunny as the value for outlook. So 5 records here. Among these 5 records, 3 of them are in the red area and 2 of them are in the blue area. Okay, so it means that among the records with sunny value for outlook, 3 of them belong to class no, and 2 of them belong to class yes. For overcast, we have 4 records, and all of them belong to the blue class, which was yes, I suppose. Yep. So yes, so four of them are yes. And for rainy, we have 5 records, 3 of them in the blue area, which means yes class, good to play outside, and 2 of them in no class, not good for playing outside. For temperature, the situation is a little bit different because the type of this attribute is numeric. For numeric values, you have several statistical factors: minimum, maximum, a mean or average, and a standard deviation. Okay? And this shows the distribution of the records for these values and the class distribution. As you see, it seems that when the temperature is pretty low, it seems that the the number of no classes is higher. When the temperature is getting warmer, the number of records belonging to class no decreases here. For humidity, again the same thing. This is numeric with these statistical factors and the distribution here. It seems that when the humidity is too high, it's not good to play outside. I don't know, probably because of the possibility of rain or something. And for windy, we have an attribute of type nominal with 2 possible values, true and false. 6 records in class true, 6 records with true value for this attribute, 8 false values. And this shows the distribution of the classes here. It seems that when it is windy, the number of no records is pretty the same as yes, but when it is not windy, the number of no records for playing outside is much lower than yes. So it means that when it is not windy, it is a good idea to play outside. So yeah, in this screen you can find some information about the attributes here. If you want to delete some of these attributes, you can click on the attribute, check the attribute, and press remove if you want. So I remove, for example, the first attribute, which was Outlook. If you change your mind, you can press undo to return the changes. So after this, I will have Outlook here. The other thing you can do with the data preparation is just clicking on edit here. If you click on edit, you can have a look at the data as a table, right? So it looks like a table, and each attribute shows 1 column here. So this is just not an attribute, it's the number of records. Outlook, nominal, the first column, then temperature, humidity, windy, and the last one, which is the class attribute. Okay. As I said, the last column is considered to be the class attribute, but if you want to make another column as class attribute, for example this one, Outlook, you can right click on that column. You will find several options here. One option is attribute as class. If you click on this attribute will be considered as the class attribute. Otherwise, as I said, by default, the last attribute is the class attribute. So it's up to you to choose this. The other option is, for example, Here, when you click on humidity, you can get average. You can set all values to something. For example, initialize all values to 0. If you have any missing values in the data set, you can set it with a default value. I don't have any missing value here, so probably that option is not applicable here. You can replace values with something. So for example, I want to replace these 65 values with 60. Okay, so I type here 60, sorry, just let me cancel that. I will type 65 and replace it with 60, for example. Okay, after press OK, you will find it changes all values 60 here and replace it with sorry, all values with 65 and replace it with 60. Again, if you're not sure, you can undo the changes and you see that it comes back to 65. So it's up to you. If you want to do some changes on the data, you can do it here. It's just a graphical user interface, easy for you. So the other one is just deleting attribute. Again, if you're not happy with some attributes, you can delete it. Or delete attributes. You can delete a set of attributes. You can sort data ascending. So for example, when I click on this sorting, it will be sorted ascending. The other one is for optimal column widths when showing the columns here. So probably we are not going to do so much to do this. After you finish with changing the data, you can press OK. And if you want to save this kind of changes, you can press on Save button here. Then you can save it with this previous name, with the previous format, or you can change the format or the name. So for example, I will save it as a CSV file. Okay, I will save it as weather numeric, and the type of the file is CSV. All right, so I will save it. If I go back to the folder here, so when it was saved, so probably I didn't pay attention to this. So it's save. So probably let me change something. So I forgot to tell you here, if you want to add a new instance record, you can press this one. It will create a new record here by default values. You can change it, for example, if you want. And this one. Okay, and then press OK, and I will go and save it. CSV, save, and let me see why it's not it doesn't save it here. So I don't know what is the problem. So let me save it in my downloads. Weather numeric. Here. I don't know what was the problem, not saving in that folder, probably because of the permission. So weather numeric is saved here. I click on this and I can easily open it in Excel. And remember that this was the new record I added to the file in Weka. So you can continue on changing the data set here if you want, because this is CSV format, and you can play with this in Excel, or you can go back to Weka and edit it here. So it's up to you. The other thing is visualizing the data. So as you see already, you have some kind of visualization here. There is another type of visualization for a scatter plot. So if you remember, I told you that a scatter plot is meant to compare two attributes against together and see is there any correlation between these two attributes. So for example, let me compare humidity against temperature. Okay, so I click here. It will show me on x-axis the temperature. This is the temperature, and on y-axis this is humidity. Okay, and I have some points here. Each point shows one record in the data file. If the class of that record is yes, the point is shown in blue. If the class for that record is no, it's shown in red. Okay, so when I look at here, I see that most of the blue records are in this area. For example, it seems that the temperature, when the temperature is not so cold, not so hot, we can play outside. But at the same time, the humidity, so the red zone is somewhere here. So if the humidity is too high, probably it's not good to play outside. Okay, so you can change the attributes here. So for example, when I click here, it drops me you know, all the attributes here. So at the moment I have temperature here versus humidity. If you want to, for example, change it to windy, for example, or outlook, for example, you can click on these values and you know, change this here. Also, you can click here and change the value of x and y on different attributes. You can here you can change, for example, the size of it, plot size, point size, and after you change the size to be effective, just and the color is just the class attribute at the moment, but you can change it if you want. Yep. Okay, so after you change the size, you can press update, and you see that, for example, it becomes bigger. After changing this, I can make it bigger, and at the first glance I can see, for example, what is the relationship between these attributes towards the classification. Okay, the other thing I want to show you is just sorry, I missed that one, so let me open that. So this time I will open the CSV version. So I will go for CSV in my downloads folder. So the same data. The thing I wanted to show you is just a kind of filters here. So there are several filters you can choose here. If I click on this, one of the filters that I may use, so assume that I want to discretize temperature. For example, in 5 categories: very cold, cold, medium, warm, and hot, something like that. This is at the moment numeric. Sometimes we want to discretize that. So for example, if your class attribute is a continuous variable, numeric, you need to discretize that before you know, applying classification. So assume that I want to discretize temperature into 5 categories or 5 bins. The way you can do that is just clicking on filter. There are many filters here, supervised or unsupervised. You can have a look and you know, get some information about this. So for example, one of the filters here is discretize. If you hover the mouse over discretize, it will show you some information about this filter and about the other filters as well. For example, normalizing one attribute, for example, numeric attribute. Sometimes we need that, and we will have a look at that one. Or nominal to binary, nominal to a string. All of these filters are possible here. So I will click on discretize. So here you will see that the parameters for discretize method, there are several parameters here. The one which is very important for me is this one. The number of bins by default is 10. I don't want it. I want to make it 5 categories. And the other one is this one, first to last. It means that all attributes from the first attribute to the last attribute will be discretized. But I don't want that. I want to discretize only temperature. Okay, so if I click on this, it will open a window for me, and I can configure this filter. There are several parameters here. The first one is attribute indices. I don't want to cover all attributes here. I want to cover only temperature. The index of temperature is 2 in this list. So I will delete this and replace it with 2. This is bin range precision. And the other one which is important is number of bins or number of categories. At the moment by default is 10, so I will change it by 5, for example. And the other one is use equal frequency. What does that mean? So if we choose 5 bins, it will divide the range of temperature into 5 equal ranges. If we choose this as yes, it will divide the length of each range based on the frequency of records or based on the number of records fall into that bin. So it tries to come up with 5 bins with equal number of records fallen into that bin. Okay, so it's up to you which one to choose. So at the moment I will keep it as false and press OK. It won't be applied to the data unless you press apply. If I press apply and come up with temperature, you see that now the temperature is of type nominal, not numeric, and there are 5 categories here, or 5 distinct values. The first category starts from I don't know, minus infinity to 68.2. The second category from 68.2 to 72.4, and etc. All right. And for each category, it shows you how many records fallen into this category and how many of them belong to class yes, how many belong to class no. As you see, the number of records in each category is not the same because I didn't choose equal frequency. So it's up to you. If you choose equal frequency, for example, and apply it, it tries to just equally distribute these records in the class, but so it's if possible it can find equal frequencies, otherwise leave it. As I said, there are many filters here, and if you want to get some information, you can read the description here. So as I said, if you hover the mouse on each filter, you can get some information here. These are the kind of operations you can apply for your data set and prepare it before starting with classification and clustering or associating rules. So these are 3 types of data mining tasks we can do with our data set, and as I said, we are going to continue this topic next week. So next week we will consider classification, further techniques, and see how can we use classification for our data set. There are many classifiers here, some of them tree-based classifiers, so we used one of them today. So as you may know, Weka is one of the most powerful tools for data mining, developed by Waikato University. You can easily experiment with data